Thanks for your time. And today, what I want to do is share our Huawei's, metro network experience to all of you. All right. And Huawei is a network vendor. Mostly, we comes from carrier side. So we are very familiar with the metro, with the backbone. So today we have some idea to share all of you, right? So here's the session for today. Today we have limited time, but we want many information in this session. So we have 3 topics. The first topic is about 5G, right? So today 5G is very hot. So what will happen? How about 5G service will impact our metro network? Okay, this is the first topic we want to discuss. And the second is about the cloud metro, okay, our traditional design, how to fulfill our HSI, high-speed internet connection, okay, around this, okay. And the third topic is about lease line. We provide metro network. We can provide the lease line service to the enterprise customer. So what changed, what happened in this market? Okay, so this is all of the 3 major topic we will cover today, right? So because time issue, let's go through it quickly. So the first thing is when we check our network, right? The first thing is we always thinking about our business case. So there's no business case, no technology, no solution, right? So the first thing is we check what business happened in our metro network. So here you will find that the first thing is about 5G. Right, today it is much more hot. Okay, more and more people were discussing what 5G were happening, and the second is about our high speed to C. Okay, to whom? Okay, the first is to 5G to mobile. The second is for to whom. How we reach a very high speed internet connection to the home. So today, the connection, the internet connection, not means only the wireline, but also about the wireless. More and more service provider, they want to provide Wi-Fi coverage in the customer's home. So it can improve the user experience in their home scope. Okay, so this is the second topic. The third is we discuss about the lease line. Today, much thing changed happened in the enterprise business, right? So compared to the past, we focus on the lease line. It's a dedicated lease line. It's a private line connect between the enterprise data center from their campus to their headquarters like this. But today, you will find more and more enterprise, their business, they go through the cloud. So all the private line, all the lease line is towards cloud. How we address the new requirement in the market, how to build the lease line very agile and very effective to the cloud, right? So the first thing, let's check about the 5G in the metro. So the first thing we check about what's happening in the 5G. What's the real requirement from the 5G? So here you will find that actually from the 5G, for the user experience side, we have 3 major factors we need to achieve. The first thing is about the speed, the bandwidth, the throughput. So you will find actually 5G is not one-stop, okay, solution. Okay, so it will give us a very high-speed 10 gig wireless connection. No, you will find actually for the 5G, our evolve is step by step. All right. So today you will find that the first stage, maybe 2 years, we will stay here the first stage for 2 years, and we will only achieve maybe it's a 100 Mbps, right? So this is the first stage, and then we move to the next round. Then finally we will got a very high-speed connection. So the reason is for the wireless interface, for the AI interface, we need to overcome many hard problems to achieve the high speed. Today, you will find only a single antenna maybe is not enough. We should use a MIMO, okay, or something beyond the MIMO to help us to improve the throughput. And the second thing is the latency, right? So you will find how to reduce the latency in the network side. You know the distance is fixed, okay, and the fiber, the distance, the length is the key factor for the latency. So the solution is we try to build the network can start to do the exchange the data from the edge. So this is the reason why today more and more edge data center will be built from the metro network. For example, compared to the past, we have maybe 4 data center, maybe 2 data center in one metro, in one city. But today, maybe you will have 10 or 16 or 20 edge data center around your core data center, right? So this edge data center, we can provide, let's say, traffic exchange or value-added service function, okay, settled in this edge data center, right? So this is the network architecture change compared to the past. More and more data center were involved in our metro network, right? And here you will find that we have the uplink and downlink, it doesn't matter. So here is some key difference we have listed, right? So you will find you will find that we have the here you will find the bandwidth, okay. So you will find that here we have the latency. You will find that we have the timing issue, right? So here you will find that for the 5G network, we need a more accurate clock. It's not a time, it's a clock synchronization. It's about the phase synchronization across the network. So it maybe not happen to compare our legacy network design, but for 5G we need this because we need the AI interface to be synchronized to achieve a co-works between two BTS, or you can think it's two different antenna. Right, so it can help us to improve the bandwidth throughput through the name is COMP, core multipass. Okay, you can think like this. So it is very, very hard for us. We need to improve the clock synchronization issue in our metro network. How we do this, and here you will find that we have the last one. We talk slicing. Okay, slicing is, you know, everyone know Flex Ethernet. Flex Ethernet actually is a technology happened under the Ethernet MAC layer. So we do a TDM time slot below the layer 2 MAC layer. So you can think Flex Ethernet, it's a Ethernet over TDM technology. So we use a time slot, okay, between the layer 1 and the layer 2 to splice. Okay, the Ethernet connection in some different time slots. So you can build a Ethernet-based TDM network, right? So this is a new thing, new technology, new innovation happening in the metro network, right? So let's next, right? So here we talk about the 5G network architecture. Okay, this is the point of view from mobile network operator. So what the network looks like from their mobile operator looks like from their viewpoint of view. So from their point of view, the first thing is the radio access network. It's a totally wireless. Okay, it's an AI interface. It's a radio access network. It will include the radio part, antenna part, maybe a little bit about DU. Okay, we call this distribution unit. It is a function split from the BBU, okay, from the base station. So this is the radio access network, okay. And the second is about the transport network. So you can think IPRAN. So many people we are talking about IPRAN network in the metro network, right? So normally when you build a metro network, you will build a dedicated IPRAN network. The reason is the quality, the traffic quality. So you want guarantee the voice traffic when the voice traffic goes through your metro network, right? So at the core network, it can be combined. But normally, in traditional design, IPRAN network is an independent network. Okay, maybe the network bandwidth is not so full, but it happens. So in some case, some of our mobile operator, they will deploy the enterprise lease line service in the IPRAN network. And another, let's say, a common design for the HSI, for the internet connection. So this is the common design happened today, right? And the third thing from the mobile operator, what we find is data center. So, So in our mobile operator, they will have a 5G or 4G core network part. You know, in the 4G network, we have a EPC core network. But in the 5G network, we have a more huge core network settled in our data center, okay? We will involve more functions, and most of them is virtualized. So you can find in the 5G network, the mobile operator need a data center with NFV function, network function virtualization component in their data center, right? So all the service will be virtualized and settled in virtual machine, and they can do the scale in and the scale out very easily. And when they put some new feature, it is also more convenience for them by leveraging our NFV technology. Right. So here you will find that this is the architecture from the mobile operator's point of view. They have the radio access network, they have the transport, they have in the transport, they have the IPRAN, they have the core network, and they also need a very good data center. Maybe it's a cloud data center, multiple data center, many data center for their core network, right? So this is from the mobile operator point of view. So what will happen from our network vendor's point of view? So here's the answer. So from our network team, from our network guy, what we looks like for the 5G network, it is like this. We have a 5G cloud control, okay? So this is the mapping to the data center from the 5G network. So we have a control cloud, or in the cloud, it's almost data center. We should provide a DCI, data center interconnection network, provide a very high-speed fabric for the data center connection, right? So for the inside something inside the data center, it is totally private for the mobile operator, right? So in the control cloud, in the data center, we don't touch. It is totally closed by the mobile operator to the outside, to the external. They have very secured design to keep their control cloud is safe. Okay, so nothing to touch inside the data center, but the network is ours. And the second thing is about 5G radio access network, right? For the radio access network, you will find that we have several scenarios. We need to do the indoor coverage. So it is very special when we talk about 5G and the 4G, right? For the 4G network, because of the frequency is in the low band, okay? So the frequency is not so high. So we use a pole or we use a tower from outside to inside coverage. It is possible. But when we talk about 5G, the frequency is a little bit high. In the 5G, we have the high band and the low band. Even the low band, it is more high than 4G, right? It is maybe, we call this sub-6G frequency. So during this frequency, in this frequency band, it is very hard to do the outside coverage to the inside, okay? Because of the, let's say, noise and because of the penetration when the radio cross the wall, cross the window, okay? So this is the indoor coverage, okay? So it is it's a very huge topic. So in our Huawei, we have the special 5G indoor coverage design to help the customer to do the indoor coverage for the 5G, okay? Even for the LTE also, right? And the second thing is we talk about outdoor. Outdoor coverage is easy for the mobile operator because we can leverage the experience from the LTE, from the 4G, from the 3G. And here, the most important thing is the we call the front haul. How we connect from the antenna back to the DU, or from the antenna to the BBU, right? We call it a front haul. So here lives some technology. We can use fiber. It is more easiest way. If you have the fiber, if you want to provide, if you want to be a provider of the mobile operator, right? Because the mobile operator, they lack of the fiber to their, to their antenna, okay, to their, to their tower. So you can act as an ISP service provider for the mobile operator. You provide the fiber, or you provide the transmission service for the mobile operator. So this is another solution, right? And here also here happens for something like that. And the last part is about the traditional 5G, barrier network, right? It is very normal when we talk about IP. Everything is IP. But here we leave two important things we need to take in our consideration. And you will find that the first thing, as I say, is the clock. How to deliver a very accurate clock signal from your network to the base station, to the antenna. And the second thing is, what about the network slicing feature happen in your network? Do you have any plan to support this, or you don't need to consider it for this? Okay. So normally, it will be maybe after 2 or 3 years. Okay, the Flex Ethernet, we wait for the ecosystem be ready, right? Here is a whole picture when we talked about 5G network. So you will find that here we will have the core network, right? And we will have the edge data center, we have the regional data center, we have the metro network to connect them together. We also will support an IPRAN connection for the middle haul, for the back haul, and we will also support a front haul with the fiber, with the transmission network, or we also support different deploy model. You know, in 5G, it's different compared to the 4G. In 4G, we have the BBU. Okay, you can think it's a base station. But in 5G, we split the BBU as two parts. One is we call CU, another a centralized unit. Another we call the DU, right? And for the CU and the DU, we have different deploy mode. So it depends on the scenario happen for the mobile operator, right? So for our ISP today, I know most of us, comes from the service, internet service provider. We haven't the mobile license. So here what we can do is we provide the connection resource for the mobile operator, right? So it can be happen in the fiber, happen in the transmission service for their radio access network, for their IPRAN network, and for the DCI, for the data center interconnection. You know, some mobile operator, they haven't a long haul, connection, especially for the high speed connection. For the 5G, you know, we will need a very high throughput between the data center, so we can provide this. Okay, so here is some some case to share with you. So here's the case for our Huawei. We co-works with Telefonica to do the verifying. This is for 5G transport. 5G transport solution. So we checked them a little. So you will find that here we have checked with the layer 3 to edge. So normally when we design the 5G network, 4G network, it's from layer 2, from the base from the tower to the gateway to the PDN, pack data gateway, pack data gateway. It's a total layer 2. So it can be layer 3. It can be layer 3, but most mobile operators, they design it with the layer 2. This is the reason from the legacy design issue. Okay, it doesn't matter. So in 5G, because we want to short the latency, so you will find that here we enable the layer 3 at here, at the cell site gateway. So the layer 3 can be exchanged locally, so it can improve the latency. And here the second thing is 50 giga Ethernet interface. It is more effective, cost effective, because we can leverage PAM4 encoding technology to help us only use just one pair of the laser to reach 50 giga speed. So today, when you talk about 100 giga, it's combined with the 4 lambda. So it needs 4 pair transceiver laser to help us to achieve the 100 giga, so 25 giga per lambda. So, but here you will find that we need only 1 lambda, only 1 pair of the laser transceiver to reach the 50 giga. So it will double our bandwidth, but stay with the same cost. Okay, and here we talk about FlexE, Ethernet over TDM. We talk about segment routing. Okay, it's a new technology we have mentioned. So here we talk about 5G microwave. For somewhere we have the fiber resource, so we can use a new microwave device to reach the rural part. Okay, so we also have the, let's say, OTN. So this is for the transmission, for the front haul. So we have the SD controller, we have the GPS, Atom GPS. It is more, let's say, compact GPS version for us. So here is some case, right? Here is some case. This case is, actually, let me check which mobile vendor. This case is for, LG. It's from Korea, LGU Plus, right? So for LGU, this is their legacy 4G LTE network. In their 4G LTE network, because they provide 4G service many years before, so the network from the cell site gateway, here's cell site gateway, to the PDG, okay, pack data gateway is only layer 2 connection. But in 5G, they will change the whole network to layer 3. So this is the reason why they build a separated. They don't want to change layer 2 network, their 4G network too much. They want to keep the service stable, right? So they have built a layer 3, right? IPRAN network dedicated for their 5G service. And they also built a dedicated, let's say, 5G core network, right? So this is a reference design for you, right? So you can know what mobile operator they want to do. And because time issue, so for the next 2 cases, I will do a little bit, let's say, speed up. This is another mobile operator. Let's call mobile operator S, okay? So you will find what's the difference is this is their 4G network. This is the 5G network IPRAN, but they combine the core network in one. Okay, compared to the previous, you will find that the IPRAN for 4G and 5G is independent, and also the core. But here you will find that the core is merged in one, okay, one core network and separated RAN network. And also from some mobile operator, they want to a cost-saving design, they just want to merge, they can leverage the 4G IPRAN network with the 5G service. It also works, but need something change in their 4G network. Okay, so here is another case, okay. This case is happened in the Western Europe. Okay, so you will find they construct a multi-vendor. Here is Huawei, here is the third party, okay. So third party for the core network and Huawei for the IPRAN network. So this is the, let's say, SD controller to talk with 2 different vendors, let's say, SD controller. So you will find here, it's a multi-vendor IP barrier network for the mobile operator. Okay. So next, because time issue, next we pass to the metro. So for the metro network, I want to talk too much, but what I want to mention is, here you will find in Huawei, you know, we are the first vendor in the taking market leadership in the access. We can provide the PON. Okay, it's a PON, GPON solution, okay, or 10 GPON solution. And in the next stage, we will provide a 50 GHz PON solution, okay? But we also provide Ethernet, ETTH, okay, Ethernet to home solution. So we have much experience here. You will find that here is our design. So here's the Ethernet switch, okay, to reach home, so it can help you to do a very high speed and cost-effective design. And here, what our suggestion is, change the aggregation network with the MPLS, so you can run over a layer 2 over layer 3. So it's a layer 3 network, but you can transport the layer 2 service across your metro. Okay, so here you can put the BNG gateway, okay, or not, depending on your design. So here is the FTT edge or FTT building or FTT watt, everything. So you will find that we can provide equal uplink and downlink speed with very high speed and cost effective. We can give you a very good experience on this for the different Ethernet switch model. So today our switch, what we think is, today the metro, you have two choices. The first choice is you still stay in the MPLS, okay? You can run segment routing, but depend on you, okay? Another case is from some some carrier side. And also service provider. They are thinking, how about run VXLAN over their metro network? MPLS is a mandatory issue, or VXLAN is more makes sense, okay? Both of them is work, okay? So it's depend on. So we can support both. And here we have the larger scale network and much more high reliability. Okay, so next we talk about, this is the FTTH. Okay, FTTH is mean to the PON. So whatever ETTX or FTTX, the new thing what we try to do is we do the network inside. We need a telemetry, just like we have mentioned, the monitoring, right? Just so when the last session we talk about monitoring, we are for me from the network vendor side, the monitoring we will change from the legacy way. It's very longer interval duration, and we read the message from the network device, maybe 1 minute, 5 minutes, 10 minutes, 20 minutes. But with the telemetry, this is the new telemetry technology. We want read the device, read the information more real time, and much more information we will retrieve from the network device. So this is so crucial in the next generation network design, right? Because it can help us more understand what will happen in the customer service. Okay, what's their experience? Are they boring or they are happy with us? So the last piece, okay, Agile lease line. So for Agile lease line, today, you know, more and more enterprise, they are towards the cloud. They are talking about lease line connection between the private cloud and their service. They will have a hybrid cloud. They will combine the public cloud or something else. So today, what we're thinking is for the enterprise, all their connection is around the cloud. So here you will find, we have two different modes. So this is China Telecom, this is AT&T. So they have provided different cloud lease line concept to the market. For the AT&T, they are coupled with the public cloud. Okay, they have the dedicated connection towards the public cloud. Right? So the customer, if they have get the network with the AT&T, so they can happy with the very good public cloud experience. So from the China Telecom, they are a little bit different. They want try to provide the public cloud service by themselves. So they have a package with the enterprise customer. Please migration your private cloud towards China Telecom's public cloud, and they can offer a very, competitive package to the market. So this both of two strategy also works. Okay, depend on the market, the local market requirements. So here is the challenge. When we talk about the lease line connect to the public cloud, what will happen? So you will find a long time to market, okay? So when the customer asks for the lease line, asks for the connection, how to improve it, okay? So you will have you will got a very, urgent event, okay? Urgent work, task to finish this. And the second thing is operation and management, how to measure. So the answer is very simple here, you will check. So normally, so the enterprise goes through the public cloud, go to their private cloud, maybe through their lease lines, maybe through the internet. So what we need to do is we build the cloud gateway towards the public cloud directly. Okay, we predefine this. And when the enterprise asks for the connection towards the public cloud, we just build a virtual lease line across the metro network. So you will find we need SDN controller to help us to do the auto provision and also the measuring through the telemetry technology I have mentioned, right? Do you know? So telemetry is a big topic, and most of the customers, they are talking about how to standardize the telemetry today between different network vendors, right? So you maybe want a multi-vendor network, Huawei and Cisco maybe and Juniper, but you were facing different telemetry interface. Maybe different vendor will give you different, data and even the format and the structure, data structure. So how to standardize the telemetry is very, very important. So here is some reference design. We are talking about the deployment. So too detailed, skip this. So last is the summary because of the time issue. So I'll do a very simple summary. So we have the 5G. We have discussed network service in our metro. We have the to home, right? Ethernet to home and fiber PON connection to home solution. We talk about lease line. This is to B, to business, to enterprise. So this is two major pieces from our metro network service. So that's all from today. Thank you.